Look at the world around you. Your phone, your coffee cup, the walls of the room you are sitting in right now. Everything you can touch, see, or measure has a definitive edge. It has a beginning and it has an end. As a scientist, my job is to measure these boundaries. But what happens when we encounter something that defies the very concept of a limit? What happens when we look at infinity? Most people think infinity is just a massive number, a placeholder for a lot. But as a researcher, I want to propose a dangerous hypothesis. What if infinity isn't a destination at all, but rather a hauntingly beautiful, endless emptiness that rules everything around us? Let's test this hypothesis and let's start small. Look at your own hand. Between your thumb and your index finger, there is a finite distance. Let's say 10 centimeters. That's a clean, measurable boundary. But mathematically, if you try to divide that space in half, and then in half again and again, you will find an infinite number of points crammed into that tiny gap. You are holding an infinity between your fingers right now. This brings us to a mathematical nightmare discovered by George Cantor. He proved that not all infinities are created equal. Imagine the infinity of whole numbers. 1, 2, 3, 4 going on forever. Now, imagine the infinity of every single fraction and decimal between the numbers 0 and 1, 0.1, 0.01, 0.000001. Mathematically, this second infinity, crammed into a microscopic space, is fundamentally larger than the infinity of all whole numbers combined. We express this in set theory using the cardinalities of infinite sets, where the countable infinity of natural numbers is represented by \Aleph_0, Aleph 0, while the uncountable infinity of real numbers is the continuum, denoted by \mathfrak C. The math proves that \Aleph_0 \mathfrak C. Now let's apply this logic to the cosmos and solve our hypothesis. When we look at an infinite universe, our human intuition fails us. We imagine a space packed so tightly with stars that they must touch. But reality is a paradox of dilution. Think about it. If there is an infinite number of stars but they are separated by billions of light years of absolute, empty vacuum, how can the empty space between them be even bigger than infinity? The solution lies in the concept of density. Just like you can leave infinite gaps between infinite numbers, the universe can be 99.9% empty, yet both the matter and the void remain entirely endless. Why then is the night sky dark instead of blindingly bright? This is known as Olber's paradox. If the universe were infinite, static, and eternal, every point in the sky should shine like the sun. The solution? The universe isn't static. It is expanding. The fabric of space is literally stretching, pushing galaxies apart, and diluting the light before it can ever reach our eyes. So, let's return to our hypothesis. Is infinity just a massive number? No. It is a fundamental law of reality that proves emptiness and abundance can coexist. Our brains evolved on the African savanna to calculate limits. 3 mammoths, a safe cave, a change of season. We are hardwired for boundaries because boundaries keep us alive. When you force your mind to grasp infinity, the cognitive system experiences a literal glitch. But as scientists, we find comfort in this glitch, because it reminds us that while our own time on this planet is strictly limited, the canvas we are painted on has absolutely no end.